Thank you, and thanks for having me back. So I'm Marit van Dijk. I'm from the Netherlands, as you can probably tell from my last name and accent. And I'm here today to talk to you about reading code. A brief disclaimer, since this is a polyglot conference. I'm a Java developer mostly. I use Java, Kotlin, other JVM languages. But I've gotten the complaint before that, all of the examples were in Java. So just so you're aware, this will contain Java. If that upsets you, if you want to leave, that's fine. I'll allow that. I won't hold it against you. As Maxime just said, we actually spend more time reading code than we do writing code. For example, if we're adding features to an existing code base or fixing a bug, when we're trying to understand a new application or code base, when we're doing code reviews, when we're learning about new technologies and reading books, blog posts, watching videos, etc. Pretty much all tasks include some form of reading code. In fact, developers on average spend as much as 58% of their time comprehending existing source code. This is from research quoted in the book The Programmer's Brain by Feline Hermans. Although I think that we might have seen some different numbers in other talks during this conference. It also depends on how the research measures the tasks that developers spend their time on. This book, The Programmer's Brain, is subtitled What Every Programmer Should Know About Cognition. And I highly recommend this book. It's written by Feline Hermans. She's a professor of computer science education at the Vrije Universiteit in Amsterdam. And you'll see some more of her work in my talk. This is also a Feline fangirl talk, yeah? We spend more time reading code than writing code, but we barely practice reading code explicitly. And when we do talk about readability of code, we often talk about how to write readable code. Which is not what this talk is about. Feline Hermans, that's her. She did a talk at Strangeloop in 2019 called How to Teach Programming and Other Things. And in this talk, she mentions research from 1992, which is before I learned programming. And in this research, they were teaching a class programming concepts, and they split the class in 3 groups. The first group would write code and read code. The second would write code and read code, but with explanations of that code. So explaining why a certain implementation was chosen, or what the reason was for certain choices in the implementation of the code. And the third group would read code again with those explanations. And what they found was that actually the second and third group, who read the code with explanations, were better able to reproduce the programming concepts that they were learning. Which is interesting because, like most people, I learned programming by writing lots of code. I found that really interesting. And after that talk, someone came up to Feline and said, hey, so what if we practice reading code explicitly? And that's how Code Reading Club was born. So they created a code reading club where they do structured exercises to deliberately practice reading code. And I heard or read about Code Reading Club at some point. I'm a huge fan of Feline's work, so I'm like, that sounds super interesting. I want to do that. And then I got really, really lucky because my friend Lissy Hokke, who is also here as a speaker, she was starting a code reading club with several people, and she asked, hey, do you want to join our club? I'm like, hell yeah, I do. So we've been having code reading clubs sessions monthly, although I'm not always able to join them because sometimes I travel. But we have a group of about 10 people where we do monthly code reading clubs. We take turns facilitating, and I want to share some of my experience with you. So during this code reading club, we will take a sample of code, which will be 1 or maybe 2 pieces of paper's worth. We take turns finding this code as well, and the people in the club work in different companies, in different industries, in different countries, in different programming languages. So we get different types of code every time. We print out the code and then use structured exercises to annotate the code. So added bonus, we get to play with colored markers, which is not something you get to do as an adult. So this is, the background is an actual piece of code that I've used during one of our sessions. And to give you an idea of what the type of exercises are, I'll share some of them with you. I've put the details in the back of the slide deck, and I'll share a link to the slides at the end. So the first exercise we usually do is called first glance. That's literally what it is. We take 1 minute and write down what the first thing is that we notice about the code and why. Or maybe if we have time, what the second thing is and why. And I find this really interesting because people notice different things. Some people will notice, oh, hey, here's a term that I know. That gives me some idea of what this code might be about. Other people are like, okay, I've never seen this syntax before. I have to know what that means in order to figure out this code. So you get different perspectives, which I really like. The second exercise we use is to identify components in the code and the relationships between them. So identify variables and methods and how they are used throughout the code. And what I like about that one is that I'm at least able to do that even if it's a language that I've never seen before, because some of the concepts transfer across languages. So that helped me also build my confidence in figuring out foreign language code. Another exercise that we often do is to identify the most important lines in this code, which is especially interesting if you don't first agree on what most important means, because you get different results. I've picked, these are the 5 lines that determine the control flow throughout the code. Someone else might say, okay, these are the lines that help me understand what this code is about. For example, those might include the name of the class or a comment somewhere. We have some testers in the group, so they obviously pick the lines where, okay, there's something going on here where I need a lot of test cases, so those are the most important lines. So again, I really enjoy learning from the different perspectives. Another thing to do is to identify concepts, and that might also include things that you need to go look up outside the code base so that you can understand what the code is about. And the most interesting thing to me is we usually end with a summary. So we take a few minutes to write down what we think the code is about, what does it do. And even though the previous exercises didn't look much at what does the code do, but look more at the shape of the code or how it's written, we are somehow, by working with the code, able to summarize roughly what the code does, which I found very interesting. So I'm a huge fan of Code Reading Club and highly recommend it, not just because I'm learning to improve my skill of reading code, which also makes me more confident that I'm able to read code that I've never seen before. But as I've mentioned several times, I really love getting different people's perspectives, also so that I know how to write code that other people can also understand, not just from opinions that people have on writing readable code, but from actually talking to people. And what I really liked is that it made me more aware of my own assumptions, because we were talking about the code and what do you notice about the code. Or also sometimes other people would pick in the first glance something that I kind of glossed over because I'm like, oh, that's not important right now. So yeah, in discussing it, it also made my assumptions more explicit and made me more aware of my own thought process in reading code. I wrote a blog post on what I think are the benefits on a Code Reading Club if you want to have a look at that. Another thing that I really like about practicing code reading explicitly is that we are practicing reading code not to judge it, but to understand it first. And I think that normally if we're reading code that we're working with, we're always, that's not how I would write this code, or that's not how I would write this code now, because I've also felt that way about code I wrote 6 months ago. Yeah. I mean, the upside is, in those 6 months, apparently I learned a lot, so now I can improve my own code, so yay. But I like having the mindset of first understanding this code before then trying to improve that code to whatever you think is better. And I think we can use more of that when we're working with other people's code, and other people's code includes your past self. So to get back to Faline's work, in The Programmer's Brain, she describes 3 reasons why code is confusing. And she mentions one is a lack of knowledge. The second can be a lack of information. And the third is a lack of processing power in the brain. And these roughly translate to your cognitive processes. So your knowledge is the things that you know, what you have stored in your long-term memory. And that could be about programming, languages, how they work, or certain domains that you're dealing with. Your short-term memory is the information that you have available right now. And your working memory is then how you deal with the information that you have available. A lack of knowledge can lead to code being confusing if you are unfamiliar with the language or syntax that is used, or unfamiliar with programming constructs or algorithms or design patterns that are used in the code. On the other hand, the business domain can also be confusing if you don't know the domain concepts or the business logic that the code is dealing with. We can deal with a lack of knowledge by creating a list of the things that we don't know. We've all probably read some code and then immediately went to Google to go Google some stuff, yes? Not just me. I tend to also end up going down a bunch of unrelated rabbit holes if I do that. So Feline recommends creating a list so that we can keep track of the things that we wanted to research, and also so we can keep track a little bit of our progress and keep ourselves on task, because there are so many interesting things to learn. But we might have some work that actually needs to get done. So create a list and research the things on your list. And if some of it is relevant, if it's knowledge that you need to store in your long-term memory, memorize that stuff, a particular syntax, particular business logic, just so that you will have it next time you need it, if you need it a lot. A lack of information can be unknown details. Say the code calls a library method and you're not 100% clear on the exact implementation of that method. It can be unfamiliar names. If you don't know the domain or the names are not as good as they could be. Code could be connected in unknown ways. You might not know where the code is called or where it might be reused. There might be too many things going on at once. We can deal with this lack of information. One of the ways that Feline mentions we can deal with this is by chunking. So who's ever heard that you can store 7 plus or minus 2 things in your short-term memory? Many people. Feline says, turns out it's actually less. It's 2 to 6 things. So if you have, for example, a design pattern that you're not familiar with, like model view controller, if you're not familiar with that, each of those parts of that concept might take up an individual slot, meaning, I have model view controller, okay, that's my short-term memory filled all the slots. If I know this pattern, it takes up only 1 slot. So therefore I have more space for other things that I can keep in my short-term memory, which is why it can be important to know the concepts or patterns that are being used. Like I just said. A lack of processing power in the brain can be if there's too many processing steps, if you chain infinite number of methods in a row, or deep nesting where too many things are going on, cyclomatic complexity. We all know what it looks like, not necessarily always how to fix it. Or if there are too many variables that you need to keep track of and it's unclear what the values of those variables might be as you're running through this code. Dealing with a lack of processing power in the brain, you can do by using memory aids, basically by offloading some of the information, like a dependency graph or a state table. For an example of a dependency graph, I took this picture from Code Reading Club. I have no idea where this code comes from, because I've had that question. So here you see that they've identified the variables and how they are used throughout the code, and that gives you kind of an idea of the flow of the code. A state table, I'm deliberately using a super or a relatively easy nested loop, but you can extrapolate to your code base of examples that you've seen. So it can help to have a state table and track the values of the variables throughout complicated code. Feline was writing another book called Code Reading in Practice, and I did read the preview version on O'Reilly, but unfortunately she's put that project on hold due to too many other amazing ideas, so I'm sure she'll come up with something else that is equally amazing. But in this book, she talks about dimensions of code reading being structure, domain, concepts, and context. So first of all, the structure of the code, we all know that code isn't read linearly. You don't start at the beginning and then read all the way to the end. It's not run linearly either, but that does pose some challenges when trying to understand how it works. In terms of the domain, we can look at the behavior of the code, what does it do, and the data that it deals with. In terms of concepts, we've talked about programming domain on one hand and business domain on the other. And in terms of context, you can think about the history. How did this code base come to be? What was the reason for it? Is it a brand new functionality? Is it a piece of a former monolith that we broke off? Are we actively developing this, or is it in maintenance mode? How does it fit in the landscape? What other applications does it interact with? A lot of things that you need to know that are outside the code base in order to understand the code base. So let's look at reading code. What if we want to get a bigger picture of an application? For example, if you're joining a new team or organization or using a new code base, maybe you inherit something from a different team, or you have to work on a shared code base, you'll have to figure out what a code base does. As mentioned, you'll need a bunch of context for that code base. Hopefully, if you are joining a new team or organization, someone on your team will take the time to give you a bit of an overview, history, place in the landscape, maybe some hints on these are the parts of the code base we're actively working on. This is the part we hardly ever touch, so maybe focus on these first. A bit of context of the things that you can't capture in the code can be really useful to know where to look in the code. So obviously, as developers, we're going to check out the project at some point so we can look at it in our IDE and search the project, etc. So let's take a look at how your IDE can actually help you when you're trying to familiarize yourself with a project. I'm going to be using my favorite IDE for reasons. So can you see this in the back? Okay, good. Actually, let me close the... So one of the first things that I might look at is to look at the source and see, look at the packages, see if I can kind of roughly figure it out from there. If we have a small project like this one, I'm using the Spring Pet Clinic as an example, as a fairly small demo project. I can look at the packages, and I see that some are more in the programming domain, and some are more in the business domain. But I can have a look and get a general idea of what this application is about. The next thing I always do is make sure that I can build the project. I mostly use Maven, so I hopefully can use Maven Clean Verify to make sure that the project builds and the tests pass. If that doesn't work, I might check the README for information on how to build a project, how to run it locally, etc. In one of the teams I was on before I joined JetBrains, we had the same way of building every project, which is nice. In the team I was on before that, we had a different way for each project on how to run it, which got confusing very quickly. And so you might look in the README to see, how do I build this project? How do I run it locally? Unfortunately, the team also had READMEs that were like, this is the repo for this project. Super helpful, right? So one of the first things that I did is to write down in the README, okay, this project, build it like this is what you need, yada, yada, yada. I know we were talking about reading code, but sometimes small contributions can be really helpful for your future self and people who might join the team in the future as well. So hopefully a README will give you the information that you need. You might want to also run the application so you can observe what it does. Upside of pet clinic is puppy tax and kitten tax. So we can look at what the application does. It's a pet clinic. We can find pet owners. We can find veterinarians. And because it's a demo application, they've also added a way to throw an error or how an error is thrown. So we can see that we get an expected error that is used to showcase what happens when you get an error. If you get this in a running application, you might need to figure out what causes that error. So either you would Google your error message, or if you're using an AI assistant, I'm using our AI assistant, obviously, you can ask AI assistant to explain that error message to you. The predefined prompt also will try to fix it. In this case, it's a demo error, so it doesn't actually need to fix it. But you can use this functionality to figure out why you're getting an error. So, that was a fairly small project. I feel confident now that I can make changes to this project. I've kind of figured out the high level, and I'll know where to find stuff that I need. What if we have a way bigger project? And here I'll use Cucumber JVM as an example. Cucumber JVM is the Java implementation of Cucumber, which is a BDD tool, or behavior-driven development tool. I've worked on this code base in the past a little bit, doing some contributions, but always in very, specific places. I've never had to figure out the entire project. So as you can see here, we have way more modules to look at. So if I needed to know what this project did, it would take me a longer time to figure out. So we might use some different functionalities. Now, I happen to know that most of these packages have a README that explains what it is. But also, I might see a lot of terminology that I don't know, so I might create a list to go look up some stuff so that I know roughly what the code base deals with. But there are other ways that I can figure out how these packages and modules are related. One feature I really like is to have a dependency matrix. So we can use this feature to get an idea of which modules depend on each other. So as you can see, we have the same modules from the project tool window in the matrix. Obviously, the rows are the same, but the names are omitted to make it fit your screen. And you can see that they are sorted in a different way. That's because the package or the modules that are used by others are sorted towards the bottom, and the modules that use them are sorted towards the top. So we can see in the legend here that the blue squares means that there's a dependency between the two. We can get more details if we hover. The 3 dots means more than 99. So in this case, Cucumber Java uses Cucumber core 209 times. That makes sense because the core defines the functionality, and Java is the old OOP Java implementation of that functionality. We can also see that the colors indicate the direction of the dependency. So the greenly marked, the module marked green uses the module marked yellow. So this will give us an idea, and we can click different modules to get an idea of what uses what. And we could use that to create our own diagram to get an idea of how the application how the modules in the application are related. We can also generate diagrams. That's not useful. Let me get this one. So here we can see a diagram of some of the same information that we got from the dependency matrix, but this is only one side. This only shows us Cucumber Core uses these other modules. Generating diagrams has ups and downs. In this case, it fits. If you have a class diagram with hundreds of classes, you end up with really tiny things that are hard to read on the screen. You'll be able to zoom in and search for it, but sometimes you don't need all of the 100 classes. You need only a particular section. So in that case, I'd highly recommend creating your own diagrams, not just so you can focus on the stuff that you need and omit the rest, but also research has shown that if you create your own diagrams, you'll be able to remember that information better than just looking at a generated diagram. A friend of mine has a talk called Wired, How Our Brain Learns Programming Languages. And she is a former educator as well. And she mentions that if we engage with the material in different ways, we're better able to retain the material. So don't just look at a diagram, create your own. Don't just look at the code, play with it, etc. So if you're onboarding to a new code base, your IDE can help you by looking at the project structure, building and running the application, looking at the README for relevant information that you need, figuring out dependencies in the project, and using diagrams. About dependencies, one of the things I always do as well is to look at the build file to see what libraries are being used in a project, to see whether they're using ones that I'm already familiar with or maybe some that I'm not, and I add those to my list of things to figure out what it's about. Strategies outside your IDE, again, is to identify components that you need to know, the relationships and dependencies between those, any concepts that you might need to research, and to get some context of things that you can't capture in the code base. Another way to figure out how an application works or what it does is to look at a specific slice of the application. And that might also be if you have a specific use case of why you need to work with a code base. You might not need to understand all of it. You might only be working at a section of the code base. To do so, we need to find a starting point. And that starting point can be generic, like a main method or an endpoint. Or it can be specific to the use case or the task that we're working on, like an error message or exception that we see in the log and we want to figure out where it's coming from, or particular logic or functionality related to a bug we need to fix or functionality that we need to change or add to. So, of course, again, our IDE can help. So, for example, if we want to look for a main method, we get too many results in this case. Yeah, if I misspell stuff, it won't find the exact string. That was very unfortunate. Anyway, so if you find the main method in certain programs, that will be helpful. You can go from the main method, see how the application works from there, find out the main flow. If you're using Spring, does anybody use Spring? I don't know how many of you are Java developers. So how many of you are Java developers? Okay, so if you use Spring, you'll know that the main method is actually not that helpful. That's where the Spring magic starts. Woohoo! So we might want to look for a controller instead so that we can find an endpoint where we can enter the application and then navigate into the application from there. So for example, here we have a post mapping. It will end up saving something in the repository. We can navigate down, and we can navigate back up again and get an idea of a slice of the application. Another place that might be useful to look at is just to look at the endpoints. Here we can navigate to individual endpoints as well. So we'll be navigating throughout our code base. If we get lost, we might look at recent files or recent locations so that we can find our way again. I sometimes end up down a bunch of rabbit holes and then losing my way. So this functionality can help you. You can also create bookmarks for yourself. So if you're looking at a particular slice of the application, bookmark the locations that are relevant for that flow. We can create anonymous bookmarks or mnemonic bookmarks that we can give a number to. Go back. So we can bookmark locations in the code and then navigate to those locations in the code. So basically leaving breadcrumbs for ourselves. So, familiarize yourself with ways to search and navigate in your code base. If we're looking, for example, for somewhere where an error is thrown. Sorry, talking and typing is hard at the same time. So we might look for a location where a specific error is thrown. We might want to figure out where we are in the code base. So there's functionality so you can see you are here. We might be moving up from that specific location and get a bigger picture. So basically like inside out instead of outside in like we just looked at. So having a project in your IDE is helpful because it's easier to navigate the project instead of a bunch of files on your computer. So strategies that we can use is using a particular use case and drawing your own diagrams, or sometimes I also write kind of like flows. This method calls that method, and to know where I need to be to make the changes that I need. Sorry? Yeah, yes, thank you. I lost the word there between too many languages this week. Bilingual. Anyway, when we finally find the piece of code where we need to be, where we might need to add some functionality or fix a bug, some code can be extremely confusing and overwhelming. I worked at a team that I worked at an online retailer before, and one of the applications that we were responsible for tracked the status of order items. So people would order stuff from the web shop, and we would have to, we obviously had a profile where you could see the status of your orders. So we had some logic that figured out, okay, something is ordered, it's canceled, it's shipped, it's rejected, returned, the return is accepted or rejected. We got that information from multiple other microservices and then did a bunch of logic. That was probably the most confusing piece of code that we had, is figuring out based on all of like 10 different numbers what the current status is of that order item. So when you have to figure out that code, yes, we have tests, but they don't really help you in how exactly it's implemented. This is where structured exercises can help, because if you're looking at a piece of code that's super confusing and you don't know where to start, now you have structured exercises, and really, honestly, any exercise will do. It will give you a place to start, and then you'll get over your feeling of overwhelm and gradually get closer to where you need to go. Obviously, your IDE can help you when you're reading code. I practiced my demo before the talk, and therefore now everything is confusing. Anyway, so when you're reading code in your IDE, you will have syntax highlighting keywords, annotations, names of variables and methods, etc. Your IDE might provide more information like inlay hints gutter icons and inlay hints. So the types of things, for example. We can also get additional information. So here we're using a customer order class. We can go to the customer order class to see what it does, or we can pull up the documentation for that class. If we have an expression that evaluates to something, we can go to see what the type is, or we can pull up the type information right there so that we have the information that we need in our IDE. Excuse me. The next thing is we will look at the structure of the code. Turns out that, again, we don't read it from start to finish, and in fact, we'll scan the code looking for the things that we need more than reading it, actually. And the more experienced we are, the better we become at scanning and quickly finding the stuff that we need. But there are some functionalities that can help us here as well. So we can collapse the code, for example, so that we see only the methods to not be overwhelmed with too much detail. And we can expand again the sections that we need, or we can search the code even though it's collapsed. For example, if we search for payment, some sections will expand. If we change the thing we're looking for, a different section might expand. Or the other way around, if we highlight a variable in the code, we can search for that and see where it's used, throughout the code to get part of our stack trace. What was it called? Dependency matrix. Dependency graph, sorry, lost my English. Dependency graph, but unfortunately if we're using the IDE for that, we can only select one at a time. If we're doing it on a piece of paper, we can do the same for all of the variables, etc. So that's the structure of the code. There are other ways to look at the structure of the code. We can get the file structure, which will list the methods, and we can use that for navigation as well. Or if we prefer it off to the side, we can open a structure tab and use that to get an overview of the code. This, again, is a class that's not too big. You can imagine that this might get bigger if you have God classes or larger classes. We might want to look at the behavior of the code by looking at the tests. And that's hoping that your application has tests, right? Okay. And depending also on how well the tests are named, I still have to fix my naming based on a presentation I saw by Kevlin Henney, where he explains why should is actually not a good pattern. But in the meantime, at least it tells me what it should be doing. So if you give your tests names that explain the intended behavior, they can serve as a kind of documentation. And also, if they tell you what it should be doing, regardless of how you phrase that, if they break in the future, that means you at least know what the intended behavior is, which will help you figure out whether you actually broke something or you have found a test that you need to update for the functionality that you're trying to update. We can run the test through the debugger to see how the code actually behaves, which can be useful, and to see the values of variables as you're running through the code. I'd already put a breakpoint. So when it hits the breakpoint, you can see the stack trace, thank you, and the values of the variables. You can step into a method to call a method that is called on that line, to actually step into the method that is called on the line, or you can step over them. One of my favorite features is you can evaluate expressions. This window doesn't always size properly. So you can evaluate an expression and see again the values of the variables, but this is also an editor window, so we can also go into more detail and even evaluate code that we don't have in our editor. And I find this, for example, really helpful if I'm trying to fix a bug or figuring out what exactly I need. I can just sort of try out some stuff to find what I need, exit, and use that code. Then, of course, we can run our application again. So looking at the tests, running tests through the debugger to observe how your application behaves. If there isn't a test for the piece of code you're interested in, add a test. That can be a useful change to add to the code base. As you're working with the code, you might also gain more understanding and, for example, want to refactor some of it. If you're reading the code for understanding, roll back all of your refactorings. But if you're trying to understand the code, it can help to kind of play with the code, maybe change it around a little bit. To change it to a style that you're maybe more familiar with, or extract some stuff as you're figuring out the steps in a longer method, or whatever. So one of the things that might happen is you might better understand what a particular variable means. So you might want to rename it. As you can see, we're also getting AI-assisted suggestions here, but we still have the regular suggestions from our IDE. Like I said, you might want to change the style of the code. So if you're not as familiar with streams, but you prefer, wrong shortcut, you prefer an enhanced for loop, you can change it to that, or back again. You might want to extract functionality. So in this case, we're adding cancellations for each order item. Maybe we want to make that more explicit and extract a method where we cancel the order item. We might want to inline variables or not. So you can kind of play with the code to help aid your understanding. And of course, if you have tests, run the tests to make sure you haven't broken anything. Although I got a very interesting suggestion when I did this talk earlier this week, which is, or break the code to see if you properly understand it. So I'm stealing that one. I gave them fair warning. So like we said, if you're refactoring the code for understanding, then roll back all of those changes. Another thing I forgot to mention is obviously you can, if you're writing code in your IDE, it will format the code for you. No, actually, let's take that suggestion. So I don't have to type. So if I'm writing code in my editor, it will format it for me. But if I find code that isn't properly formatted, I can reformat that code. And similarly, if I'm reading code in the editor, I can change the order and move private methods down and make sure that I follow conventions to make it easier for me to read the code. So many different ways that you can work with the code to make it easier to understand. We've also seen that we can look at the history of the code, so we can use git annotate to look at when a particular piece of code was, when a particular piece of code was changed. Let me find one that's actually interesting. So at some point, code was added to cancel order items if the payment has failed. We used to have, in my previous job, we used to have the habit of putting the JIRA ticket number in there so that you could go for more information outside of the code base if you want to know more about the user story when this code was changed. Obviously, we can look at a specific commit and look at the diff to see what actually changed in that commit and go over all of the diffs to get an idea. But here also we have an interesting feature in AI Assistant is that we can explain the commit, and we can also select several commits and explain those to us. It will generate a summary of what happened, which can be super useful. Let's say you've gone on vacation, you want to figure out quickly what your coworkers have been up to. You can ask it for a summary. And there are other ways that it can help you not just write code, but also understand code, like it can explain code to you, you can find problems in the code, you can write a Java doc, all of the stuff that we know is important but don't necessarily like to do. So lots of ways that it can help you work with your code other than just generating code for you. So we've looked at help from your IDE, we looked at structure, hints that your IDE provides in terms of syntax, highlighting, etc., using testing and debugging to understand how the code works, refactoring for understanding, but don't forget to roll that back, and getting some context for why the code came to be that way. Strategies outside your IDE, use structured exercises. I'll give you some places that you can find some exercises. Use memory aids like dependency graphs and state tables. Gain context from your teammates and your coworkers on the history of the code base and the context in which it operates. So what's next for you? Hopefully I will have inspired some of you to try Code Reading Club. So if you want to get some structured exercises, Code Reading Club have a website. They do virtual events. Unfortunately, I just checked before coming here. They don't have events scheduled at the moment, so you can start your own club with your team or your coworkers who are interested. They have resources on GitHub where they have 3 or 4 sessions already planned out with a sample of code, which is not as easy as you might think to find a sample of code that fits 1 or 2 pages. Exercises that you can do with that code, notes for the facilitator on how to facilitate the session. So I highly recommend using that. And of course, Feline's book, The Programmer's Brain, has lots and lots of exercises. So even if you can't find like-minded people to start a club with, you can use the book or those exercises to at least practice on your own. Obviously, let your tools help you, but don't forget to use your brain and evaluate, especially if you're using AI Assistant, evaluate the results that it gives you. Sorry? Yes, hallucinations, but also like I've tried asking AI Assistant, can you explain this project to me? Spring Pet Clinic? Sure, no problem. But that's part of its training data. Cucumber JVM? Not so much. No, not until I started prompting it. It started because it uses Spring somewhere. It started saying, oh yeah, this is a web application. Not even close. So then you have to tell it, okay, this is actually the implementation of, and then it will start spewing stuff about Cucumber JVM and BDD. So eventually it'll get there, but depending on how standard it is and how much like its training data, you might need more prompts.
To be able to actually understand what it is saying.
Yes, so we still actually need to be able to read code. And in fact, I've gotten the question, so with AI Assistant, now that AI assistants can write code for us, do we still need to read code? Because I just saw a talk at this other conference where someone just built an application without even being able to code. Do you want to maintain that code? Because, well, no, actually I do, job security for life. So, if you use the code that AI generates for you, you still need to understand the code that it generated, just like the code that you copied from Stack Overflow, because once you commit that code, you own it, and you have to be able to maintain it. So, don't forget to use your brain, which was the previous slide. I'm Marit van Dijk. You can find the slides for this presentation and related content like blog posts and videos that I've done on features on that page, as well as my socials. If you do start a code reading club and want to let me know how you get on, I'd love that. If there are any questions. I don't know how much time we have for questions. Otherwise, I'll be around all day, so...
Just one thing, when starting with a test, and we always do, and there is a small thing we all can do, divide in sectors like given, when, then, it really simplifies things. With that, we are...
Yeah, or... Arrange, act, assert is a similar thing, like set up the state, your begin state, do the thing where you want to verify the result of the action, and then do the verification. And some people put this in comments, given, when, then, to make sure that they follow. I tend to use white space and make sure that the first section is the given or arrange, the next section is the act, and the last section is the asserts. I can do a whole rant on how not to do your tests as well, but, find me in the hallway or ask me back. Yes?
Thank you for your talk. My name is Natalie. I have this compliment to the talk. I'm not sure how to say it. You mentioned a very interesting study in the very first slides.
Yes.
What they said is that explanation, like we are discussing the code, this
Yes.
is what yields the
Yes.
result.
Yes.
And so the pedagogy or the learning science says that there are 3 main criteria for good learning: atmosphere or the culture.
Yes.
We are actually safe to discuss, safe to show that we don't understand. Then
Safe to ask questions.
Yeah, then the discussion itself as the process and the practice, as you've said.
Yeah.
What really works well for me in my code writing clubs is that we did pairing, but with juniors, with those who lack knowledge. Because when we explain what we read, we enable the discussion. When we are stuck, when we don't know what we're reading, we enable the safety, this psychological safety.
Yeah.
And when they write and we write code, this enables the practice.
Yeah.
So I always encourage everyone to onboard junior developers.
Yeah. The downside of pairing only with juniors is that there might be trouble with the... No, help me out. Kenny left. No, the power imbalance between people. And so you need the safe learning environment again. With the AI assistant, you kind of get your intern or junior to do some grunt work for you, but then you're missing the training the new juniors for the future. So if you do that and no longer train juniors and interns, you can't complain about there not being any seniors to hire. Just saying.
With the power structure, it's interesting. If you are one senior and if you have 5 juniors, then the safety is there because they see everyone is failing. It's all right.
Yes. Also make it safe to fail with stuff. So and in terms of the explanation, so if you use the AI assistant explain code action, it will actually explain the code to you. So that can be super useful. Any other questions? Yes. Yes. Well, because if you're new to a code base, you don't want to... Yes, so the question was, I mentioned rolling back the changes that you made when you're refactoring the code for understanding. Why should you always roll them back? Because you're refactoring for your understanding. You're refactoring to a style that you prefer at that time, that you might be more familiar with. But the new code base that you're onboarding to might have a different style. So I'm not saying never commit refactorings. I mean, absolutely refactor to make the code better. But if you're playing with the code to help your understanding, throw that stuff away. It's okay. If it's an important refactoring that you learned from, you can do it again.
Thanks.
Thank you. Yes, behind you, if you pass it.
Any tips for dealing with frameworks that you're not familiar with? Like you said, Spring does its magic. If I don't know Spring, then
If you don't know Spring, listen to Josh's talks, because they're amazing. He's amazing. But play them at half speed, because he's so fast. Anyway, so something like Spring, you can actually ask AI Assistant to help you explain some stuff. Although there are limitations because of the magic and the convention over configuration. I've also seen examples where an AI assistant can't help you because it's like, very specific stuff that you need to know. And also depending on your favorite way of learning, read blog posts, read books. If you prefer reading to learn, like me, I like reading and also being able to scan a piece of text or a blog post or documentation for the things that I'm looking for. If you prefer videos, great. There's lots and lots of video courses, videos by Josh and talks and everything. But I find they're harder to scan to look for something in particular. So, but if you're starting from scratch, that might be a good idea. Anyone else? I don't know when it's time. So if anybody has any questions, I'll be around today. Thank you.